Okay, so if we take a look at the expression for I, one way to tell that the expressions are not equivalent, that they are different in value, is by applying the distributive property. So if we have 4 times x, so 4, we multiply the coefficients, 4 times 1 is 4, so we'd get 4x. And then here we'd have 4 times, and we're going to look at this as a negative 2, so 4 times negative 2 is negative 8, so we put minus 8. So it should equal 4x minus 8, which is not 4x minus 2. So they are different. Another method to show that they are different is if we take the two expressions, and since it's a variable expression, variables stand for numbers, so I'm going to make up a random number for x, and I'm going to let x equal 5. So if I take away the x and plug in the 5 here, we do parentheses first, so that's 3, and a 4 next to parentheses means times, so we would get 12. If we take out this x and we plug in a 5, a 4 next to an x means multiply, so here we'd get 20 minus 2, which is 18 over here. So they are not equal, so they are indeed different. Okay, so for letter H here, one way to show that they are different is if we apply the distributive property, we'd have negative 5 times 2x, so we multiply the coefficient, or the 2 next to, or times the negative 5, so that it would equal negative 10x, and then we'd have a negative 5 times a negative 1. So again, we're doing negative 5 times negative 1 here. So negative 5 times a negative 1 would make positive 5. So as you could see, this is not equivalent to negative 10x minus 5. So this has a plus 5, whereas this one had a negative 5 there. Okay, another way to prove that these are not equivalent is to pick a random number for x. So I'm going to let x be 4. And I'm going to take out this x and put a 4 in. Order of operations says we do the parentheses first, so 2 times 4 is 8. 8 minus 1 is 7. So this negative 5 is next to the parentheses, so we know that this means to multiply here. So we get negative 35. Now we're going to put that same 4 here, and a negative 10 next to an x means multiply. So we'd have negative 40 minus 5 is negative 45. So as we can see, they are not equivalent. Okay, so if we look at letter I here, one way to tell that these are equivalent is if we use the commutative property, they could be written the same way. So if we break this up, this looks like 4 next to an x means multiply, x squared means there's 2 of them being multiplied, and then times y. So this is what this expression here looks like. Whereas over here, this one is 4 next to a y, that means times, and then x squared looks like this. So these two here are the exact same. This is saying that 2 x's are being multiplied, same thing here. Then we have a y here, we have a y here, we have the 4's here. So they are the same. So in other words, if we use the commutative property and change the order, in other words, this one here is in alphabetical order. X comes before y. If we apply that commutative property here, this can be written as putting this next and then the y last. So now, by moving the variables around there, they are equivalent. Okay, another way to prove that they are equivalent is to assign values for x and y. So I'm going to randomly make up. I'm going to have x be 3, and I'm going to have y be 2. Okay, so totally make up numbers. And then if we had 4 times x, which I picked was 2, and then an x squared next to an y means times. So if we compute this, we'd have exponents first, so that's 9. And then we'd have 36 times 2, which is 72. Now if we do that same thing here, we'd have 4 times, and y is 2, and our x is 3. So we know with order of operations, we always do exponents first, so that would be 9, which is what we got here. And then if we do 4 times 2, that's 8, and then 8 times 9 is also 72. So we get the same value for both of them. So therefore we know that the values are indeed equivalent. Okay, so for letter J we have 1/2 and 0.5. So one way to show that they are equivalent is if we change the fraction to a decimal. So if we do 1 divided by 2, it gets us 0.5. So they are indeed equivalent. Another way to show that they are equivalent is if I read this decimal, this is read as 5/10. So 5/10 looks like this. And 5/10, 5 is half of 10, so it simplifies to a half. So they are the same. Okay, so for letter K, one way is to use the distributive property. Remember, this negative out in front of the parenthesis represents the word opposite. So it's saying, what is the opposite of x plus 3? So the opposite of x is negative x, and the opposite of plus 3 is minus 3. And as we can see, that's what we have over here. So they are indeed equivalent. Some teachers also show that you could think of it like you have a -1 out here, and a -1 times 1x is -1x, and -1 times +3 is -3. You can also think about it that way, but it's saying what's the opposite of x plus 3, which is -x minus 3. Alright, another way to show that they are equivalent is pick a random number for x. So I'm going to have x be 5. So I'm going to put a 5 here, parentheses first, so 5 plus 3 is 8, and then we bring down the negative, so we get -8 here. If I plug in the 5 here, we'd have -5 minus 3, which is also -8. So they are equivalent expressions. Okay, so when we look at letter L, a -3 here next to a parenthesis means multiply. So a -3 times 2, a negative times a positive is a negative, and 3 times 2 is 6. So we get -6. Over here we have positive times a negative is also a negative, and 2 times 3 is 6. So they are equivalent.